In this lesson, we're going to learn how to factor trinomials. To start with, we are going to review what we learned last week when it comes to multiplying polynomials. So in this warm-up, notice how it says, given the dimensions of a rectangle are 2x plus 2 by 3x plus 5, what is the area of the rectangle? So if you remember, we have a binomial by a binomial, and we use what we call the box method to multiply. So to start with, I'm going to set up, because it's a 2 by 2, I'm going to set up my 2 by 2 box. And so I have a height of 2x plus 2, and I have a length of 3x plus 5. And so I'm going to find the area of each individual box. So the first one has an area, so 2x times 3x has an area of 6x squared. 2x times 5 is 10x, and 2 times 3x is 6x. Then 2 times 5 is 10. 6x and 10x are my like terms, and I'm going to combine them. And so I have a total area of 6x squared plus 16x plus 10. So this is my area, and here are my dimensions. Well, in the next example, notice how they're giving you the area and they're asking for the dimensions. In other words, we're working completely backwards. So it says if the area of a rectangle is x squared plus 4x plus 3, what are the dimensions of the rectangle? Fill in the blanks. So notice how we've got it set up, and notice how the x squared term is here and the constant is here. That's always been the case when we multiply a linear binomial by a linear binomial. The first box has always been the quadratic term, the last box has always been the constant, and the diagonals have been our linear terms. So when I have it set up this way, it makes it easier for me to find my dimensions. So what are my only possible dimensions if I'm going to have an area of x squared? Well, the only thing I can multiply together is x times x. Now let's talk about 3. So if I have an area of 3, well, what are my only possible dimensions? So think about factors of 3. What times what is 3? Well, the only two factors of 3 that I can possibly have is a 1 and a 3. Now, they could both be negative, but in this situation, that's not going to be the case. So if this is a 1 and this is a 3, now I can help fill in my inside. So x times 1 is a 1x, 3 times x is a 3x, and what do you know? 3x and 1x combines and adds to 4x. So now I know that my dimensions are x plus 1 by x plus 3. What you have just done is you have factored a trinomial. So let's look at the next one. So in the next one, if I have an area of x squared plus 8x plus 7, I have to find the dimensions. So again, we're going to set it up. The first box is going to be the x squared, the quadratic term. The last box is going to be the constant. And these two boxes are always going to be the linear terms. They're always going to combine to make whatever that middle term is. So if I have an area of x squared, what are my only possible dimensions? X by x. So why is it that I'm going to start here and here? Well, you see, these two have to add to 8x. And when I think about it, I've got a lot of options that could be. I mean, 10x take away 2x, or 3x plus 5x. I mean, my possibilities are endless. The thing is what's special is whatever these two numbers are, they have to multiply or be factors of 7, but notice how they're going to have to add to 8. Well, let's go back to our factors of 7. So my factors of 7 are 1 times 7, and the only other way I can write it to get factors of 7 is -1 times -7. So which one does it have to be? Well, if I make it a -1 and a -7, well, okay, here, we'll just use a pen. If I make it a -1 and a -7, that's going to be a -7x. That's going to be a -1x. And those don't add to 8x. -1x and -7x adds to -8x. So this option's not going to work. So what does that mean? That means that they both have to be positive. So x plus 1 and x plus 7. 1 times 7 is positive 7. X times positive 1x is a 1x. 7 times x is a positive 7x. So now those two add to a positive 8x. So factors of 7 that have to add to positive 8. So we have our factors, x plus 7 and x plus 1. So again, working the opposite direction. How do you find the dimensions when you're given the area? So let's take a look now at the next 4 examples. And as you progress in this, notice how it gets harder as you go.